For section 6.1, we're going to talk about algebraic expressions and formulas. This is going to be kind of our introduction to the two chapters we cover that cover algebra, okay? So chapter 6, chapter 7, those are our algebra chapters. Chapter 6, we're going to cover linear equations and inequalities in one variable. We're also going to look at quadratic equations. And then we're going to, in chapter 7, look at linear equations and inequalities in two variables. Then we will look at technically exponential and logarithmic functions, but mostly we're going to look at quadratic functions. So this is kind of the start of that algebra talk, okay? For topic 1, we need to just introduce the idea of an algebraic expression first. We need to know what an expression is before we dive into an equation. So we do need to start with some definitions, okay? Now, this should technically be review. I still want to cover it all, but I am going to cover it with a little bit more speed because this is something that you should know coming into this class. Okay, so first and foremost, algebra is the branch of mathematics that uses variables in place of numbers. This is the time in math when you start seeing X's and Y's and Z's and things like that, okay? And in case you don't know what a variable is, that's our next definition. So a variable is a letter or a symbol that takes the place of an unknown value. Think of it almost like a placeholder for a number. We don't know what the number is yet. That's our goal. That's our mission to figure out what that number is in many cases, but we don't know what it is. Okay, so the variable just acts as a placeholder. Okay, in this class, we're going to stick to just letters. So we're going to use letters of the regular old alphabet. You'll see lots of X's and Y's and maybe some N's. Okay, so just regular old letters of the alphabet. Okay, next up we have a constant. A constant's a different critter. So a constant is a fixed value that does not change, okay? So it's going to be a number that kind of hangs out all by itself, all right? So let's consider something like 2x minus 5, okay? This is an example of an algebraic expression. We'll get to that definition in just a bit. But we have two pieces here. We have 2x and then we have minus 5. That 2x piece is going to change depending on what x is. So if we plug in different values for x, that piece is going to change consistently based on what x is. But this negative 5, it is a fixed value. It's never, ever going to change. It's going to stay negative 5. That is a constant. So this right here is a constant. So a fixed value, we call it a constant. Okay? That leads us to the next definition. So the next definition is a term. Okay, so a term can be a variable, it can be a constant, or it could be the product or quotient of a variable and a constant. However, when you multiply or divide variables and constants, that constant is no longer a constant once you multiply. Okay, it becomes something else, the next definition in line. But you can have a variable all by itself, you can have a constant all by itself, you can have some number multiplied by a variable or divided. You can have a variable divided by a number. But in that case, that number is no longer a constant. Okay, now what is really important to understand is terms, these kind of like building blocks of algebra, they're always going to be separated by addition and subtraction. Okay, so if we go back to this 2x minus 5, we have two terms. This right here, let me go back to the marker. This is a term. So 2x is a term. And then 5 is a term. Okay, notice the 2x has no plus or minus in front of it. Okay, we use the addition and subtraction that separate terms to tell us if that term is positive or negative. Okay, so we can see right off the bat 5, that term is negative because we have a minus in front of it. However, the 2x, we would go ahead and say it is positive. So if there's nothing in front of a term, like the first term, if there's nothing in front of it, we assume it's positive. If we put the little minus in front of it, that of course would make it negative. Okay, so for another example, you could have something like x squared plus 3x minus 12. This expression right here has three terms. So this is term 1, this is term 2, this is term 3. Okay, the first term x squared, it has a positive, it's positive because there's nothing in front of it. The second term 3x, it is positive because there's a plus sign in front of it. And then the third term 12, it is negative because there's a minus in front of it. Okay, so those are your terms. And then next up, we have a numerical coefficient. We generally just call it just a plain old coefficient. So in the previous definition, I told you that a term can be a variable by itself, it can be a constant by itself, or you can multiply a variable and a constant. But when you do that multiplication or division, that number is no longer a constant. It's no longer a fixed value. Instead, it can become a coefficient or part of a coefficient. So a numerical coefficient is the number factor of a variable term. So when we use the word factors, those are things that are being multiplied. Okay, so if we have a variable term, that variable has been multiplied by some number. The number that we multiply the variable by becomes the coefficient. Okay, so we have several examples sitting here on the board. So if I'm gonna, let me go to like maybe green. If I look at 2x minus 5, so I look at 2x, the 2 would be the coefficient. So I would say there we go. I would say the coefficient of the 2x term is 2. If I look at 3x, okay, whoops, let me undo that. Let me see if I can undo it without, there we go. If we look at 3x, 3, the numerical factor of that term, that is our coefficient. But then we have something tricky like x squared. What would the coefficient be there? Well, we don't write it, but this x squared has technically been multiplied by 1. So we would go and say, okay, the coefficient here is 1. Okay, so anytime you have a variable term, you have a coefficient. It can be 1, it can be -1, it can be a very obvious in your face number. Just know that with variable terms, the numerical factor is your coefficient. Okay, and finally, that leads us to our last definition right here. We have an algebraic expression, okay? So an algebraic expression is a combination of numbers, variables, and operation symbols. Essentially, kind of another way to think of an algebraic expression is you can think of it as the sum or difference of terms. Okay, so if you have a series of terms and you add them and subtract them, bam, you've got an algebraic expression. Okay, so anytime you have variables, numbers, and operation symbols, those being plus, minus, multiplication, division, you can also have square root. You could also think of exponents. Whenever you have that kind of stuff along with variables and numbers, you've got an algebraic expression. Okay, now for us, we are going to do really just two things with algebraic expressions. We can evaluate an algebraic expression. That means we take a very specific value for the variable and we plug it in and see what we get. Or we can simplify an algebraic expression. And the best way to get people to understand simplifying is imagine you have a bunch of crumbs on a table. Okay, you have like a kid, they made a mess with their dinner. You brush up all of those crumbs into piles. Okay, that's kind of what we do with algebraic expressions when we simplify them. We get terms that look the same, that have like a consistent thing going on with them, and we pile them all up into one single term. Okay. So we'll do that in a separate video. For this video, we are going to just label the parts of our algebraic expressions. In video 2, we're going to evaluate algebraic expressions. In video 3, we're going to do a property called the distributive property. Then in video 4, we'll do simplifying algebraic expressions. Okay, so for this first example, example 1, it just says label the different parts of each expression. Okay, so what we're looking for is what are the variables? Do we have any constants? What are our coefficients? And what are our terms? Those will be the things we're going to look at. So for our first expression, we have 3x squared minus 5xy plus 2y. So let's first talk variables. What are the variables for this expression? Well, we have x's and we have y's. So we're going to say the variables are x's and y's. Okay? Now, next, let's talk about terms. So what terms do we have? How many terms do we have here? Well, I see a plus sign and a minus sign, so that means I'm going to have 3 terms. So I've got 3 different terms separated first by subtraction and then by addition. Okay, so my 3 terms are 3x squared. It is positive. There's nothing in front of it, so it's going to be a positive. We then have negative 5xy. That minus makes the whole term negative. And then we have positive 2y squared. So notice when I have a positive term, I don't write the plus in front of it. The plus is assumed, okay? With a negative term, you have to put the minus or the negative sign in front of it, okay? Now, coefficients. Ooh, let me see if I can squeeze that in. For this first term, our coefficient is positive 3. So we have positive 3 times x squared. So that numerical factor is our coefficient. For the second term, we have negative 5 times xy. So the numerical factor is negative 5. That's our coefficient. And then for our third term, we have 2 times y squared. So the number factor would be 2. So coefficient positive 2. All right. Now, the last thing I would ordinarily want to look at would be a constant. In this case, we don't have a constant. We don't have a fixed value here. Everything is attached to a variable. So I would put none. We just don't have a constant for this expression. Okay. Now, for part B, we have something that looks kind of crazy at a glance, but it's going to have the same pieces and components as part A, nothing to get worried about. We have negative 12 a to the third b to the second minus a to the second times b plus 7ab squared minus 9. Okay, so we have one term, two terms, three terms, four terms. You can see those four terms, they're going to be separated by addition and subtraction. So let's first figure out what our variables are. Which different letters of the alphabet do you see? That's going to be your variables. We have A's and we have B's. Be really, really careful with A's and B's. They can be super, super tricky. Not that they're hard to work with. They're perfectly normal to work with. It would be just like working with an X or a Y. But you need to make sure that you don't make them look like 9s and 6s. Okay, so be really careful and make sure they very distinctly look like an A and a B, not a 9 or a 6. Okay, now as far as our terms go, we have four of them. So the first term has a negative in front of it, so that tells me it is a negative term. So I've got negative 12, a to the third, b to the second. My second term has a minus in front of it, which makes that term negative. So I get negative a to the second, b times b is what that means. When you put two variables side by side with nothing in between them, the assumption is they're being multiplied. Third term is going to be positive because there's a plus sign in front of it. So I get 7ab squared. And then my last term is minus 9, so just negative 9. All right. For the coefficients, for my first term, I'm taking those variables and I'm multiplying it by negative 12. So the numerical factor of negative 12 is my coefficient. For negative a squared times b, it doesn't look like I've multiplied the a squared times b by anything, but that negative really means I've multiplied it by negative 1. So this is negative 1 times a squared b. For the third term, I've multiplied ab squared by 7. And then my last term, I don't really do anything with constants. We, in this class, are just going to do coefficients with variable terms. All right. And then finally, do we have a constant? And the answer would be yes. We definitely, well, let me put constant. We just have one. Do we have a constant? The answer is absolutely. It is negative 9. So that's a fixed value. It's not attached to a variable. It's never going to change. Okay. So hopefully this was largely review. I'm very hopeful that you've at least seen these definitions before. Okay. If you're rusty and it feels a little like, ooh, get to the tutoring center, watch this video maybe more than once, get into my lab and get some practice behind you. Okay. So in the next video, we'll talk about evaluating algebraic expressions.